Question number 4, exercise 2.2. A is a square matrix having elements in the first row 1, 4, 4, in the second row 4, 1, 4, in the third row 4, 4, 8, 1. The order of the matrix A is 3 cross 3, and we have to multiply the matrix A with the matrix A, which is equal to A square. The condition for the multiplication of the matrix A with the matrix A is satisfied. That is, the column of the first matrix is equal to the rows of the second matrix, and the multiplication is simple. Multiply the first row with first column, 1 multiplied by 1 plus 4 multiplied by 4 plus 4 multiplied by 4. Again multiply the first row with second column, 1 multiplied by 4 plus 4 multiplied by 1 plus 4 multiplied by 4. Again multiply the first row with third column, 1 multiplied by 4 plus 4 multiplied by 4 plus 4 multiplied by 1. This resultant element is equal to 1 plus 16 plus 16, 4 plus 4 plus 16, 4 plus 16 plus 4. Again multiply the second row with first column, 4 multiplied by 1 plus 1 multiplied by 4 plus 4 multiplied by 4. This resultant is equal to 4 plus 16. Multiply the second row with second column, 4 multiplied by 4 plus 1 multiplied by 1 plus 4 multiplied by 4. This element is 16 plus 1 plus 16. Multiply the second row with third column, 4 multiplied by 4 plus 1 multiplied by 4 plus 4 multiplied by 1. This element is 16 plus 4 plus 4. Similarly, multiply the third row with first column, 4 multiplied by 1 plus 4 multiplied by 4 plus 1 multiplied by 4. This element is 4 plus 16 plus 4. Multiply the third row with second column, 4 multiplied by 4 plus 4 multiplied by 1 plus 1 multiplied by 4. This is 16 plus 4 plus 4. Multiply the third row with third column, 4 multiplied by 4 plus 4 multiplied by 4 plus 1 multiplied by 1. 16 plus 16 plus 1. Now the resultant element is 16 plus 16, 32 plus 1, 33. 16 plus 4, 20, 20 plus 4, 24. 16 plus 4 plus 4, 24. 16 plus 4 plus 4, 24. 16 plus 16, 32 plus 1, 33. 16 plus 4, 20, 24. 16 plus 4, 20, 20, 24. 16 plus 4 plus 4 is 24. 16 plus 16 plus 1 is 33. Which is equal to A square. The order of the resultant matrix is 3 cross 3. There are 3 rows and 3 columns. Now we have to calculate A square multiplied by 1 over 3. A square is this one matrix. Multiply this matrix with a scalar 1 over 3 minus 2A. A is this matrix, origin matrix, and multiply this matrix A by a scalar 2. And minus 9 identity matrix. The order of the identity matrix will be 3 cross 3 because the order of the matrix A is 3 cross 3, so 2A will be 3 cross 3. The A square is also 3. The order of A square is 3 cross 3, and when we multiply A square by 1 over 3, the order of the resultant matrix will also be equal to 3 cross 3. And there is the operator between 2A, 1 over 3 A square minus 2A, and 9 identity is minus, so the subtraction will be possible only when the order of 2A and 9 identity is the same. So the order of the identity matrix will be 3 cross 3. So this is a 3 cross 3 identity matrix, and multiply this identity matrix by 9, and the procedure is, so now multiply each element by the scalar 1 over 3 and multiply each element of this matrix by the scalar minus 2 and multiply each element of this matrix by 9. So multiply 33 by 1 over 3 and subtract from when we multiply the matrix, the element 1 by minus 2, we get minus 2, and multiply 1 by 9 and subtract. So these are the elements in the first row and first column. Substitute this element in the first row and first column, multiply this the element of the first row and second column by 1 over 3, and multiply the element of the first row and second column by 2, and the element of the first row and second column by 9, and apply the operator negative. We get this element in the first row and second column. Similarly, multiply the element in the first row and third column by 1 over 3, and the element in the first row and second column by 2, we get minus 8, and the element in the first row and third column by 9, and operate with the operator negative. Similarly, and so on. After the simplification, we get this resultant element is 11 minus 11, this element is 8 minus 8, and this element is 8 minus 8, this element is 8 minus 8, this element is 11 minus 11, this element is 8 minus 8, this element is 8 minus 8, this element is 8 minus 8, this element is 11 minus 11. The resultant matrix is which we obtained is a zero matrix. Therefore, each element of the resultant matrix is 0. So this type of matrix is called zero matrix or null matrix. The order of this matrix is 3 cross 3 because the order of A square and the order of A and the order of identity matrix is 3 cross 3. So the resultant matrix, the operator between them is negative. So the order of the resultant matrix will be the same as the order of A identity and A square, which is 3 cross 3. This matrix is equal to the zero matrix which is required.